Hello everyone. Before diving into today's topic, we want to take a moment to thank you for your support. Every like, comment, and subscription really makes a difference and helps this channel grow. If you enjoy our content and don't want to miss upcoming videos, subscribe to the channel and activate the bell to receive all notifications. SpaceX's Starship program is among the most ambitious projects ever undertaken in the history of aerospace engineering. Designed to be fully reusable, the Starship vehicles promise to revolutionize the very concept of access to space. It's not just about building a bigger or more powerful rocket, but about radically changing the economic model of space launches, opening up new possibilities for both robotic and human exploration, on the Moon, on Mars, and perhaps even beyond. The ninth test flight of the complete system, consisting of the Super Heavy first stage and the Starship vehicle, is shaping up to be a crucial proving ground. After the partial successes and explosive failures of previous flights, each test becomes a fundamental piece in understanding the engineering, operational, and structural challenges of a vehicle of this size and complexity. Starship Flight 9, Integrated Full System Flight, comes after a long series of updates and revisions. The previous flights, particularly IFT-7 and IFT-8, highlighted major issues, including engine instability, loss of control, and difficulties with atmospheric re-entry. Throughout 2024, SpaceX implemented thousands of changes to the vehicle's design, launching a new generation of Starship called Block 2. This represents a significant design evolution, with targeted improvements to nearly every component, from engine layout to thermal insulation, from avionics systems to flight control. One of the main differences in the Block 2 model concerns the engine area. The new design aims to improve resistance to high temperatures, mechanical robustness, and the reliability of propulsion systems. SpaceX has also begun the gradual introduction of the new Raptor 3 engines, which promise superior performance, greater efficiency, and less structural complexity. However, for production reasons, Flight 9 will still be mostly equipped with Raptor 2 engines, adapted to the new Block 2 architecture. Despite this compromise, the test represents a fundamental step in verifying the compatibility between the new design and the currently available engines. At the beginning of May 2025, SpaceX conducted two static fire tests on Ship 35, the vehicle designated to fly in the ninth launch. The first test, conducted on May 1, involved a single engine, aimed at simulating an in-orbit ignition. This type of ignition is crucial for controlled re-entry and for future missions involving landings on planetary surfaces. The second static test, conducted the following day, saw the simultaneous ignition of 6 engines, 3 atmospheric Raptors and 3 Raptors optimized for vacuum. During this test, one of the vacuum engines displayed abnormal behavior, abruptly cutting thrust. Footage captured by independent observers shows irregular flames and an unusual noise, signs suggesting a possible internal malfunction. The test was aborted after just 30 seconds, half the planned 60, reinforcing the hypothesis of a significant technical issue. Despite being among the most advanced engines in the world, Raptor engines are complex and delicate systems. Extreme temperatures, high pressures, and turbulent flows place severe stress on materials and electronic components. After the test, Ship 35 was removed from the launch pad and transported back to the integration site for inspections. Due to the metal shielding surrounding the engine area during transport, it was not possible to visually verify any damage. If the damaged engine needs to be replaced, part of the structure will have to be dismantled and another static fire test carried out. This could push the flight date from mid-May to the end of the month or, in case of more serious problems, to June. However, there is also the possibility that the issue is secondary, manageable with a simple calibration or replacement of minor electronic components. The success of the Starship program is not only relevant to Elon Musk's company. NASA has selected a modified version of Starship as the lunar lander for the Artemis program, specifically for the Artemis 3 mission, which aims to return humans to the lunar surface within the decade. A potential delay in Starship's development could therefore have national and even international repercussions. NASA is closely monitoring each test flight, collaborating with SpaceX on a wide range of tests, including those related to orbital refueling, a critical component for future lunar and Martian missions. Parallel to technical developments, SpaceX achieved a symbolic yet significant milestone. Starbase, the launch site located in Boca Chica, Texas, has been officially recognized as a municipal entity. On May 3, a popular vote approved, with over 97% in favor, the transformation of the area into an autonomous city. Starbase can now rely on greater administrative autonomy, facilitating the management of infrastructure, urban planning regulations, and essential services for staff. This step also signals the growing stability and permanence of SpaceX operations in the region. The intention, as declared by Elon Musk himself, is to turn Starbase into a global hub for space conquest, a starting point for missions to the Moon, Mars, and beyond. Starship is not just a rocket. It is the heart of a vision that aims to make humanity multiplanetary. The goal is ambitious: to build a fleet of vehicles capable of transporting hundreds of people to Mars on a regular basis, contributing to the creation of self-sufficient settlements beyond Earth. Every test, every flight, whether successful or not, represents a building block of this dream. Flight 9 will be no exception. It is a crucial verification of the new Block 2 design, a test of the ability to integrate more sophisticated technologies, and a concrete step toward the first fully reusable orbital flight. The future of Starship is uncertain, as are all pioneering endeavors. But what makes this project extraordinary is the speed at which SpaceX learns from its mistakes and implements improvements. Unlike traditional space programs, where every failure means a major delay, SpaceX adopts an iterative approach, where even setbacks are learning opportunities. As we await official news on the final launch date, one thing is certain: when Starship flies again, the world will be watching closely. Because every ignition, every maneuver, every controlled re-entry is a small step forward toward that future which, just a few years ago, seemed like pure science fiction.